Oh, hi, Doc Harmon here. I really like cookies. You probably do too, right? Have you ever made a cookie at home? Now, a lot of people buy those tubes with cookie dough in them, and you slice it off, put them in a pan, make cookies in the oven. Have you ever made them from scratch? Flour, butter, sugar, milk, chocolate chips. Mix those all together, put them in the oven. You get cookies out, 350 for 10 minutes, okay? Now, what happened in there? What happens is the heat of the oven changes all of the things that are in there. Now, as you know, everything is made of chemicals, so I'm going to say the chemicals were changed by the heat of the oven. Now, if you take the dough, the cookie dough that you make with chocolate chips in it, and you put it somewhere, seal it up, let it go for 3 years. You take it back out, it might be hard, but it won't be a cookie, right? The heat of the oven acted as a word that you need to know, catalyst. Catalyst makes things go faster. You may have heard of catalytic converters in cars that get rid of the noxious gases. It makes things happen that ordinarily would happen very slowly, happen very quickly. That's what catalysts do. This whole thing today is about catalysts. What does this have to do with fizzies? It's all catalysts. Now, a chemical reaction, a chemical change, is when you start with one group of chemicals or one chemical and it gets changed into something else. In our case, because it's fizzy, we are going to produce a gas. And this particular one we're going to do, actually two, one is going to make a gas called carbon dioxide. You've all heard of that. The other one is oxygen. So chemical reactions change things from one group of substances to another group of substances. It may emit gas, it may get hot, it may change color, but all of those things are going to be catalyzed by catalysts. Now I'm going to start with the one fizzy thing that almost everything that you look at is TV shows, things you do at home, all involve baking soda and vinegar to make carbon dioxide gas. Now you may have seen, if you haven't you should, seen the video that Margie did about a volcano eruption. Now what I'm going to do is to give you the picture of what happened in the volcano eruption without the volcano, okay? Take a look at this. Okay, I'm going to start with the baking soda. I'm going to put some baking soda in this carafe. You can do this at home, by the way. This is very easy to do at home. Very not dangerous. And I'm going to put some water in there. Stir it up a little bit. I'm going to wait a moment and let it dissolve. I think that'll be enough. Now the thing that actually makes it foam is dish soap. So adding some dish soap, and just for emphasis, a little bit of color. That's optional, of course. Mix it all up really well. Now some of the soda hasn't gone into solution, but that's fine. Next, I'm going to add the vinegar. You know what's going to happen. Voila! This is the basis for almost all of the fizzy things that you see online. Do it at home, have fun yourself. If you do it in a soda bottle, it'll actually squirt out the top a little bit. Now let's move on. Now for the next part of the program, we are going to do 4 really interesting and some say amazing experiments. And they all involve hydrogen peroxide. Hydrogen peroxide is something that you may have in your bathroom cabinet. It may be that you have used it to put on cuts and it bubbles a little bit. But we are going to use hydrogen peroxide, some of it pretty concentrated, and we're going to see how it breaks down and produces not carbon dioxide gas, but oxygen gas. Now the fact is that in your bathroom, hydrogen peroxide slowly breaks down. And after 6 months, it is definitely not the concentration that you bought in the store. It has diminished considerably. So you really need to replace your hydrogen peroxide at least once a year, because it will go to simply water and the oxygen will have bubbled away. But we can speed up that reaction, and we're going to use several catalysts. Remember that? We're going to use several catalysts. One of them at the end, which is going to be an experiment we call elephant's toothpaste, uses a separate chemical that you don't necessarily see every day. The others use an enzyme. Have you heard the word enzyme? An enzyme is a biological catalyst. It's a protein that's basically in every cell in your body. Why is that? Because it breaks down hydrogen peroxide. Again, why is that? Because your body, as part of its whole biochemical system, makes lots of hydrogen peroxide. Yes, it makes lots of hydrogen peroxide, which is deadly. And if you don't get rid of it really, really quickly, then you are not going to survive. So there is an enzyme which is found in almost all living things that have that have hydrogen peroxide in their metabolic scheme. Almost every cell in your body has that. Now, that enzyme, which is a protein, is the catalyst. So to start with, I'm going to show you an interesting thing about a potato. A potato, believe it or not, has catalase. Watch. Now this is the hydrogen peroxide we're going to use. You'll notice it has something called 40 volume. That was used in a beauty salon for bleaching hair. It is much stronger than what you have in your bathroom. And this should only be done by an adult, because it can be very dangerous in terms of giving you burns. Now I'm going to put the peroxide to the side, and then watch carefully as I drop these potato slices in. Look what happens over them. See those little clouds of bubbles coming up? That's catalase in the potato trying to get rid of the hydrogen peroxide, because it too can't survive if it does not get rid of the hydrogen peroxide that its cells produce. Now we're going to try something even better. So what's better than a potato? Liver. And we are going to use that because it has lots of catalase in it. Why is that? Because our livers are where a huge number of reactions go on for digestion and all kinds of things like that produce hydrogen peroxide. So the liver is loaded with hydrogen peroxide. So there is lots of catalase. Catalase is the enzyme that's in there. Now I'll tell you, just on the side, catalase is like one of the 2 most powerful enzymes in the body. We would not have survived all these years if we did not have catalase to get rid of the hydrogen peroxide our body produces. So let me show you what we're going to do. We are actually going to chop this up really fine and then just dump it into hydrogen peroxide. But for added color, a little bit of food coloring. For added fun, a little bit of soap dish, soap. But anyway, come in close and I'll show you what we're going to do with this. The first thing we have to do is to slice up the liver into smaller chunks with this knife. This is going to take a little while. Now when we've got it about this fine, I'm going to use, believe it or not, a garlic press. I'm going to put the liver in here and I'm going to squeeze it into this bowl, which really breaks it up fine. Really gets it nice and juicy. And I'm going to add a little bit of water just to loosen it up. Give it a little stir. And we're almost ready to move on to the next part. Now we're ready to actually do the experiment. I have the carafe back, something to catch the overflow. We have our powerful hydrogen peroxide into the carafe, which we had baking soda in before. Going to add a little dishwasher soap, coloring again. Now we're ready for our catalyst, which is the liver enzyme catalase. Have you heard the word catalyst before? When you make slime, you know you have to put glue and catalyst together. That usually is borate or borax, something like that. This is our catalyst, liver. Liver, that's the source of it. And the enzyme is catalase. Are we ready? That's how fast the liver can get rid of the hydrogen peroxide. Now, did you notice how that came out of the carafe in a big, like, fat tube? Sometimes they call that elephant's toothpaste. Well, the next two things we do are also called elephant's toothpaste. And something I want you to remember, and it may be the only thing you'll remember today, but I talked to the head veterinarian at the Bronx Zoo. He told me it's silly for elephants to have toothpaste because they have 5 sets of teeth. Not like a shark, which has hundreds, but elephants have 5 sets of teeth. No need to brush. But from what it looks like, we call it elephant's toothpaste. Now this next one we call rainbow elephant's toothpaste. And to do that, we need catalyst, which in this case is not potatoes, it's not liver, it's a chemical called potassium iodide. Mix a little water with it. That becomes our liquid catalyst. We're going to use a little more of that later on, but I wanted to show you how I make it. Now, come in close so I can show you the details. Now for this one, we start with hydrogen peroxide, just like we always have. And a little bit of dish soap. Bubbles, you know. But this time, I'm going to put food coloring not down in the middle, but down the sides. Now it's time for our catalyst. Fresh funnel. A little bit of a swirl. Here we go. Well, the colors got all mixed up this time, so at least you get the toothpaste idea. Let me turn it just a little bit. Well, since the rainbow didn't really show up in that one bottle, I think I'm going to try it with the 3 different colors in 3 different bottles. I'm going to use the same thing. I'm going to use peroxide, I'm going to use dish soap, I'm going to use food coloring, and the catalyst, which is potassium iodide. Now, since we're going to do these things kind of at the same time, I've asked Lisa, who you know from all the things she's done with the museum, to help me out. Now first, I'm going to put the peroxide in. After that, I'm going to put the dish soap in. A little bit more. Get rid of the funnel. And after I put the dish soap in, Lisa's going to come by and put all the coloring in. Soapy, soapy. More soap, and more soap. Now we'll swirl them around a little bit, get everything nice and mixed. Now I'm sure we're going to get some of the brown color because what we are producing is free iodine, which is brown. Iodine is an element. We used to use it for putting on cuts and things. But anyway, we're ready to go. And we're going to pour the potassium iodide catalyst right into these bottles. Oh, that's better. That's a lot better. Oh, I'm happy that worked out like that. Well, you can imagine I'm ready to have my cookie again. Next time you have a cookie, think about everything that went into it, all the ingredients, putting in the oven. It heated up. What was the catalyst? The heat from the oven. Things changed, and it was all chemical reactions. So long. Next time, Doc Harmon.